This is activity 4, revisiting the amusement park, from lesson 12, using graphs to compare relationships. And in this activity, we have Noah and Diego. They are back at the amusement park and they are moving towards their favorite rides. And so Noah is going in one direction towards one ride, and Diego is going in another direction towards a different ride. And after 8 seconds, how far are they away from the ticket booth? Well, Noah is 17 meters from the ticket booth and Diego is 43 meters from the ticket booth. And so the question is, which graph is which friend, Diego and Noah? So here's a graph. This is the distance traveled from the ticket booth, and this is the amount of time it took to travel that distance from the ticket booth. So it says, explain how you know which line goes with which friend. So first of all, the key numbers are 8 seconds. Noah has traveled 17 meters and Diego's traveled 43 meters in that same 8 seconds. So pick a time and call that 8 seconds. So I'm going to call this time right here 8 seconds. And how far has one person traveled in that 8 seconds? This is the distance in 8 seconds. This is the shorter distance. So this is going to be the 17 meters. This graph up here is the farther distance in that 8 seconds. So this is going to be the 43 meters. This is the ticket booth. So distance from the ticket booth, 17 meters from the ticket booth and 43 meters from the ticket booth, both in 8 seconds. You go up here, 8 seconds, 17 meters, and 8 seconds, 43 meters. So you just look at the story and you can tell that Noah is the 17 meters. Noah was 17 meters away. So this graph right here is Noah. He's moving slower. He's not going as fast. So the slant or the steepness of his graph is less than the steepness of Diego's graph because he's moving faster. So it's taking, in the same amount of time, he's moving farther. So that makes his graph steeper. If there was a third person who was moving even faster out here at a farther distance, his graph or her graph would be even steeper than Diego's graph. So the steepness of the graph, when the axes are set up this way, distance compared to time, the steeper graph is going to be the faster graph. Not always true. You have to really look carefully at what the labels of the axes are, because if it was reversed, no, let's not get into that. All right. So let's look at Noah's speed. Noah's speed is 17 meters per 8 seconds. So if you simplify that to what's his distance per 1 second, that's his speed. So he travels at 2 1/8 meters per 1 second. So that's the speed. Now, the distance he travels per meter, not the distance, the time it takes him to travel each meter is his pace. So it takes him 8 seconds to travel 17 meters. That means that it takes him about a half a second, 47 hundredths of a second, to travel 1 meter. So notice that these are reciprocals. This is about 2 meters in 1 second, and this is about a half of a second for 1 meter. So those are reciprocals. The reciprocal of 2 is 1/2. And so this is the constant of proportionality, his speed. So he's traveling a certain distance per time. So this is the y value, this is the y-axis, and this is the x-axis, the time. So that gives you a constant of proportionality. But notice his pace is the reciprocal of that constant of proportionality. So it's 8 seconds per 17 meters, which simplifies to approximately a half a second per meter. So that is the reciprocal of the constant of proportionality. And we want to know the second one. We want to know his pace, because I want to figure out how long does it take Noah to travel 43 meters. So where's the point out here at which he reaches 43 meters? Well, you figure out how long does it take him to travel 1 meter. So it's about a half a second for 1 meter. And then you multiply that times the 43 meters. So in 1 meter, it takes him 47 hundredths of a second. That means in 43 meters, it's going to take him 43 times as long. And so the answer to that is 20 and 2/10 seconds. You just do that on a calculator, 20 and 2/10 seconds. Now look, it's about half of 40. So 43 is very close to 40. 47 hundredths is very close to 1/2. 1/2 of 40 is 20. So that tells you that you did the calculation correctly, even though you did it on a calculator. So it's 20 and 2/10 seconds. So it's out here. So extend Noah's graph out here and extend the 43 meters this way where they intersect. That tells you the time that it took Noah right here to travel 43 meters. Now, what I want to know also is how long does it take Diego to travel 17 meters? So that's right here. What's this time? So when Diego's traveled 17 meters, how long did that take him? So that's the time right here. So I want to figure out what that time is. So in the same way, I'm going to figure out his constant of proportionality. It's 43 meters per 8 seconds. Now notice, 40 divided by 8 is 5. And so 43 meters divided by 8, it's going to be a number close to 5, a little bit more than 5. So it's 5 3/8 meters in 1 second. But I want to know his pace. This is his speed, but I want to know his pace because I want to know how long it takes him to travel 1 meter. Then I'm going to multiply by 17 to figure out how long it takes him to travel 17 meters. So his pace is about 2/10 seconds per meter. So that's about 1/5 of a second. Notice over here is about 1/2 of a second. 1/5 of a second is less time to travel 1 meter, so he's moving faster. So this is the reciprocal. So it's 43 meters per 8 seconds. The reciprocal of that is 8 seconds per 43 meters. That's going to give you Diego's pace. And his pace is about 2/10 of a second per 1 meter, 1 meter. And you multiply that times the 17 meters, and that tells you that it takes Diego about 3 23 hundredths. It's about 3 1/4, 3 1/4 seconds to travel that 17 meters. Now, as you look at all these numbers, you start to see relationships. You know, what's the relationship between 17 meters and 43 meters? What's the relationship between 3 23 hundredths seconds for Diego to travel 17 meters and 8 seconds for Noah to travel 17 meters? What's the relationship between Noah traveling, Diego traveling 43 meters in 8 seconds and Noah traveling 43 meters in 20 2/10 seconds? Is there some number that is consistent in comparing all of those values? And in fact, there is. Diego is how many times faster than Noah? So let's look at the first comparison, which is how many times faster is Diego than Noah? And you can divide Diego's speed, 43 meters per 8 seconds, by Noah's speed, 17 meters per 8 seconds. That's going to tell you how many times faster Diego is than Noah. How many of these 17s can you get out of 43? That's how many times faster Diego is. So 43 meters per 8 seconds divided by 17 meters per that same 8 seconds. That simplifies to just 43 divided by 17. Since they're both per 8 seconds, you can just divide 43 by 17. These 8s cancel out. Those are the 8 seconds. So it's 43 divided by 17. So that is about 2.5 times faster. And we got a hint of that over here. When this was 1/5, 19 hundredths of a second is about 1/5, and 47 hundredths of a second is about 1/2. Well, 1/2 is 2.5 times larger than 1/5. We'll look at that in just a second. But we start to get a hint of that relationship from there. So the relationship throughout this problem is going to be 2 53 hundredths times as you make these comparisons. In this case, it's 2 and 53 hundredths, about 2.5 times faster that Noah is traveling, that Diego is traveling than Noah. So if you compare the times, 3 and 23 hundredths times this 2 and 53 hundredths, which is how many times faster Diego is than Noah, you're going to get Diego's time. So you're going to get Noah's time. So I'm going to take Diego's time, multiply it by that 2 and 53 hundredths, and I'm going to get Noah's time. This is more time to move that same number of meters, 17 meters. Likewise, I'm going to take Noah's time and multiply that. Oh, I'm mixing this up, sorry. I'm going to take Diego's time for 43 meters right here and multiply that by 2 and 53 hundredths to get Noah's time for that same 43 meters out here. This is why I'm not redoing this video to fix up my mistakes. I want you to see the struggle that you have to go through to keep things straight. You have to move slowly, carefully think about each number that you're looking at, and say the right words. If you say the wrong thing or write the wrong thing, do it again. Try it again. All right, so let me put this into one last slide that kind of, in essence, combines this idea of 2 and 53 hundredths being the connection between several comparisons. So I'm going to reproduce this graph on this page. Same graph. Here's Noah's graph. Here's Diego's graph. Here's 43 meters, 20 and 2/10 seconds, 17 meters, the 8 seconds, and the 3 and 23 hundredths seconds for Diego to travel 17 meters. All right, so Noah 17 meters to Diego 43 meters. The relationship going from 17 to 43 is 2.5. He goes 2.5 times farther. He's traveling 2.5 times faster. Diego to go from 3 and 23 hundredths seconds to Noah's 8 seconds, again, multiply by 2.5. You're going to go from 3 and 23 hundredths seconds, about 3 1/4 seconds, to 8 seconds. For Noah, this is Diego, 8 seconds to Noah's 20 and 2/10 seconds. This is this 8 seconds to Noah's 20 and 2/10 seconds. That is also 2.5 times. So what I'm doing is I'm looking at 17 to 43. That's 2.5 times. I'm looking at 3 and 23 hundredths to 8 seconds. That's 2.5 times. That's the 17 meters. And I'm looking at 8 seconds to 20 and 2/10. That's 2.5 times. And that's the 43 meters up here. And I said earlier that the 1/5 of a second for Diego's pace and the 1/2 of a second for Noah's pace, that relationship is also 2.5 times. So Diego's pace is about 2/10 of a second per meter. Noah's pace is about 5/10 of a second per meter. That's about 1/5 of a second per meter for Diego's pace, and about 1/2 of a second per meter for Noah's pace. So this is faster. It's moving just 1/5 of a second in 1 meter. That's faster than taking 1/2 of a second to move that same meter, and they are related by that same 2.5 times. So I hope this makes sense. I would go through this carefully and just think about it. All right.